Okay, we're going to carry on with naming, and I want to show you what we're going to do when we have different formulas, so when it's skeletal formulas and when it's structural formulas. But before we get to that, I want to show you this first example here as the displayed formula. So as you can see in this one, we're going to do exactly the same thing. We're going to identify the functional group, in this case, alcohol. But you can see that there's two. There's one here and there's one here. Okay, so we're going to do the same. Functional group is an alcohol. Count the longest chain. So our longest chain is going to be 1, 2, 3, 4. We are going to number it so that our functional groups get the smallest number, which in this case would be 2 and 3. But because there's two of them, when I'm going to name it now, I will say on carbon 2 and carbon 3, there is the alcohol group. There are 4 carbons in total, so it's bute. Okay, so I'm going to say butane. But now because there's 2 alcohols, I add the word di. So I say it's a butane diol because there's 2. Just like when we had 2 methyl groups, we said dimethyl. You say the same thing even though it's a functional group. Because there's 2 of them, it's now a diol. Okay, so if we look now at something like the skeletal formula. So remember, each point in the skeletal is a carbon. So here is a carbon, here is a carbon, here is a carbon. Okay, so I have 1, 2, 3 carbons. I can see that this is a double bonded oxygen to that middle carbon, which means it's going to be a ketone. So now I know I have 1, 2, 3 carbons, and on carbon 2 is the double bonded oxygen, but because there's only 3 and it's a ketone, I don't need to number it. So I say 3 carbons is prop and known for the functional group. Okay, if you want to, you can draw this whole thing out as a straight chain just to see and make sure if you are unsure about how many points you have. So if we look at the next one, now I have a structural formula. So remember, a structural formula is when I've taken away all the bonds and I'm only showing my atoms, my carbons and my hydrogens, and I go in the order that they're attached to one another. So when I see something like this, if I want to name it, the easiest thing for me to do is to draw it out so that I know that I've got everything in the right order before I name it. So this carbon is attached to 3 hydrogens. So I have a carbon with 3 hydrogens. That's then attached to another carbon. So this carbon is then attached to my second one with 2 hydrogens, which is then attached to another carbon, okay, with 1 hydrogen. Then I've got brackets. So remember, brackets means that this whole thing in the brackets is attached to that carbon before it. So on this same carbon, I have the CH3 that's attached to it. Then I go to the next carbon, which is attached to this one before the brackets. So I have a CH2, and then my last one, CH3. So my structure looks something like this. Okay, so now that I know what it looks like, drawn out with all the bonds, now I can count my longest chain. So I've got 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, or 1, 2, 3, 4, or 1, 2, 3, 4. Okay, so 5 is my longest. No matter whether I name it forwards or backwards, the side chain is always going to land on the same number. So then I number my carbons. Okay, and on carbon 3, I have a methyl because there's 1 carbon there. And with 5, that means pent, and it's an alkane, so it's pentane. Okay, if I look at the next one, another structural formula. So now I've got a CH3 and then in brackets, CH2, close brackets, and then it says 3 of them. So when they do this, it's just a contracted form, which means that there are 3 CH2s in a row. Okay, because we always want the simplest version for the structural, sometimes they contract it like that. So if I draw it out, I have carbon with 3 hydrogens attached to another carbon with 2 hydrogens 3 times, which means there's going to be 1, 2, 3 in a row, which is then attached to another carbon, which is attached to an oxygen and an oxygen and a hydrogen. So I know carbon has 4 bonds. So if this is attached to CO, okay, that means this carbon has an oxygen attached, which is then attached to an O and an H. And I know that here I'm missing a bond, so this must be double bonded O for a carboxylic acid. So when we have a carboxylic acid, we write it as COOH. So now I have my chain drawn out. I can count the carbons. Functional group on the end must always have the smallest number. So I can say 1, 2, 3, 4, 5. So 5 carbons is pent. Because it's a carboxylic acid, I know that functional group means it's going to be pentanoic acid. And there is my name for that one. Okay, so if I look at a few more, starting with this one, I've got a skeletal formula again. So as I said before, each point is a carbon. You can either choose to draw it out or you simply just write your carbons in there so you know that those represent carbons. And a point there that doesn't have any lettering, so no O's or anything like that, means this point is also a carbon. So that means that is a side chain. So if I count my carbons, 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, or 1, 2, 3, 4, 5, 6 being the longest. Okay, and I want this side chain to get the smallest number. So if I go from this side, 1, 2, 3, 4, 4 is the side chain. Or if I go from this side, 1, 2, 3. So 3 is smaller than 4. So I have to start numbering here. And I say 1, 2, 3, 4, 5, 6. So on carbon 3, there is a 1 carbon side chain. So that's a methyl. And there are 6 carbons in the chain in total, so that is hex. And since it is an alkane, I say hexane. Okay, now if I look at this one, so again, each point is a carbon. Even those are carbons because there's no other lettering there. Okay, so if we have to look at our numbers now, 1, 2, 3, 4, or 1, 2, 3, 4, 1, 2, 4, 1, 2, 3. So 4 seems to be our longest, no matter which way we go. If I start on this end, my side chains will get the number 2. If I start on this end, they will get a number 3. So since 2 is smaller, I start here and I say 1, 2, 3, 4. Okay, so now on carbon 2, there is 1 carbon and 1 carbon. Those are separate. Each one of those is their own side chain because you can see there is 2 branches going to it, coming off of that carbon. So that means I have 2 1 carbon side chains. So just like before, we say on carbon 2 and carbon 2, we have dimethyl because there's 2 methyl groups, both on carbon 2. So you have to number both. You have to say 2, 2, because it's indicating that each of those methyls is on the same carbon. And 4 is bute, and since it's an alkane, it's butane. Okay. Now if we look at another structural formula, like this one, here I've got a CH3, okay, so to draw it out, C with 3 H's. Now I've got a C attached to that previous one, which is then attached to an O and another O. Okay, so we draw one up and one forward because that O is then going to be attached to the next carbon because it's not in brackets. So it doesn't mean that both of those are going to be up or down. That one is then going to be in the middle. Okay, so now we know that carbon has to have 4 bonds. So we've got 1, 2, 3, which means that one of these has to be a double bond. Okay, if we carry on with the chain, that's CH2, CH2, and then CH3. So now, looking at it this way, you know that you have an ester. And remember, esters, wherever we have our bond of our oxygen in the middle, we break it up. So the side with the double bonded O came from the carboxylic acid, and the other side came from the alcohol. So if I look at that, the carboxylic acid side has 2 carbons, and the alcohol side has 3 carbons. So now I'm going to say the alcohol side comes first, and there's 1, 2, 3. So I know that's prop, and I say yle, okay, from the alcohol. And then the carboxylic acid has 2 carbons, so that's F and NO8. Remember, we have the O8 from the carboxylic acid and the yle from the alcohol. Okay, and then if I look at my last example that I'm going to show you with the skeletal formula, again I have side chains. So for each point I can fill in the carbons. This one now is a point to another point. So this is now a 2-carbon side chain because that carbon is connected to that carbon because it's one thing. And then that is single. Okay, so if I look at this longest chain, 1, 2, 3, 4, 5, 6, no matter which way I go, if I start on this side, that gets the 2 and that gets the 3. So that's the smallest numbers. So I can say 1, 2, 3, 4, 5, 6. So on carbon 2, I have a methyl. On carbon 3, I have 2 carbon side chain, and 2 carbons is eth. So I have an ethyl. Okay, so I have 2 methyl, and I have 3 ethyl as the side chains. Now, our general rule says that all of those side chains need to be placed in alphabetical order. So even though the methyl is attached to a 2 and the ethyl is attached to a 3, it doesn't matter about the numerical. We put it in alphabetical, and E comes before M. So we say 3 ethyl, 2 methyl as my name. And then I name my major chain, which has 6 carbons. So that is then hexane, because we've got an alkane. So my overall name would be 3 ethyl, 2 methyl, hexane. Okay, and that's it.